Hello everyone, welcome to Unique. In this video, we're gonna discuss function of complex variable. Please subscribe our channel and be our family. Thank you for your support. Let's start from the definition of complex variable. Complex variable, it is a rule that assigns to each complex number z in set D or a unique complex number w. That means a function, our function is f such that it maps from D to complex number such that for all z an element of D, there exists some w an element of complex number such that f of z is equal to w. Then we cite this the number complex, or our function is in terms of complex number. That is what we call a function of complex variable z. Here the set D is called the domain of the function. Fn, the set of all images, is called the range of f. So we can express z by x plus I. This is denoted by z is equal to x plus iy. Here we have z is equal to x plus iy. That means x is the real part of a complex number and iy, this is the imaginary part of our complex number. The image is also written in the form of w is equal to u plus iv. Thus f of z can be expressed in this form if our w is equal to w plus iv, and if f is equal to f of z is equal to w and w is equal to u plus iw, then f of z means f into x plus iy. So generally we can express complex number of in terms of two variable. F of z is equal to f into x comma y. That means u of x comma y plus iv. This is the real part and this is the imaginary part. Okay, let us see some examples. Express each of the complex function in the form of, in this form, in the given form. For example, we have f of z is equal to z raised to 2 plus 3z. Here we have z times z bar. It means z bar is the conjugate of z, and here we have a raised to 3z. Okay, let's write them here. Let x plus iy, z is equal to x plus iy down. Z square means what? X plus iy the whole square. We put the value here in the place of this, in the place of that. Then we get x plus iy square plus 3 into x plus iy. Now when we multiply this, we get x square plus twice of ixy plus I square y square plus 3x, 3 times x means 3x, and 3 times iy, 3iy. Then here we have x square, then here we have again twice of what? Ixy plus 3x plus what? I into twice of xy. When we collect the like terms and when we solve, or for when we simplify it, we get this. Then it is a form of f of x comma y means u of x comma y plus iv of x comma y. Here we get this, the form, the original form, or the form we have to find to ask it. Let's try another example. F of z is equal to z times z bar means if z is equal to x plus iy, then what? F of z bar means z bar, it is conjugate is x minus iy. So z times z bar means x plus iy times it is conjugate x minus iy. Then when we multiply this in it is conjugate, we get the value of x square minus iy square, because here minus ixy minus ixy will be cancelled. Then minus of I square is minus 1. So here we have another minus of minus is plus, then plus y. Okay, you can do another examples associated with complex number or converting a given form into complex form. Okay, limits and continuity of complex function. Next we will see the limit and continuity of a complex function. Limit of complex function intuitively. If we have a complex number L, it is said to be a limit of a complex function at z naught is equal to a plus bi, because when we talk about complex number, we have a real part and imaginary part. That is, when we select a point in terms of, we have to select in terms of a plus bi. If f of z gets closer and closer to L as point z is equal to x plus y, then z denote a plus bi. That means limit the limit as z goes to z denote. Z denote means this one. F of z is equal to the limit as x tends to x and y tends to b. X tends to a and y tends to b, f of xy is equal to L. Then L is, or a complex number L is said to be a limit of the complex function of these four. Okay, limit in terms of real and imaginary parts. That means if f of z is equal to f of x comma y, that means it is the original form of complex number. Then if we have a point z naught, which is a plus bi, and if we have a limit or some complex number L is equal to u naught plus ib naught, then the limit as x as z goes to z number z naught, f of z is equal to L, means our L is what? U naught plus I v naught. That means here if and if only if the real part of our limit tends to u naught and imaginary part of our limit is equal to v naught, then we have what? L is equal to u naught plus I v naught, which is a limit of our complex function. This approach has dual implication. That means one hand is still as the limit of the complex function exists if and only if the limit of a real part and its imaginary part also both exist at the same time. Okay, so how to find the limit of complex number? We have find the limit of complex number by using different methods of finding limits in function of one variable. Likewise, we can also apply those methods in this part. For example, by factorization, we can evaluate the limit. For example, factorize the denominator and denominator and cancel the factor that's post-trouble. That is the same as when we deal with a real number. So evaluate the limit as z goes to zi, z raised to 4 minus twice of I z cube over z square plus 4. That means z square plus 4 means we know that when we separate this, it is z minus 2 z plus 2. So we can here we can factorize it like this. If we make here, if we figure out z cube from the numerator, we left what? Z minus 2i. Then we factorize this z minus 2i. If we cancel this, we left z cube over z plus 2i. That means when we when we directly substitute 2i in this expression, in this equation, we get minus 8i over 4i. That means by 2 is equal to minus of what? By 4 is equal to minus of 2. That is the limit of this. So when we ask her to find a limit of complex number, you have to realize that what you do in real number system, it is the same, more likely. The difference is here minus I and I. So minus I square means minus 1. So you have to consider this and realize the limit in a real number system. Okay, let me see another example. So how to do this example? For example, the limit as z goes to 3i, z square plus 3 over z minus under root of 3i. To find this limit, you have to do what? Is rationalizing. That means z plus it is conjugate, rationalizing or multiplying by its conjugate. For example, we have here asked that the limit of this, then when we multiply it by its conjugate is z plus under root of 3i, then we get 2 under root of 3i, which is a limit. That means 2 under root of z, that means z tends to 3i, then it gives us 2 under root of 3i. So by using this method, you can also do another examples by using factorizing. The next one is rationalizing. So we have seen one example. The above example is about rationalizing. Then continuity of complex function. A complex function, when you think about continuity of a complex function, you should have to think immediately continuity of function in a real number system. It is the same, but here is a different is what here our z is complex number. In what? In a real number system there is x. So if the limit as x tends to some a, f of x is equal to f of a, then our function is said to be what? Continuous. Here also the same works for complex number. Z tends to say if our function z naught or z is our complex function, then z naught is said to be continuous point if and only the limit as z2 tends to z naught f of z is equal to f of z naught. Then here, if the limit of f of z when we tend or when we extend z to z naught is equal to f of z naught, or by direct substitution, the value we find by direct substitution, if it match or it can be equal, then our function f of z is said to be continuous complex function. Okay, for example here, show that, let me see, or let me show you one example. Show that f of z is equal to z plus 5i over z square plus 4i plus 6 is continuous at z naught is equal to 1 minus 2i. Okay, here we have first to find what? The limit as z tends to z naught, then equate to f of z naught. Okay, when we find the limit of this, we get that the limit of this one, our z naught is 1 minus 2, so our z tends to 1 minus 2i. Okay, then you can use different rules of or factorization, rationalizing, or finding the limit.